We're live. How's it going? I'm not gonna lie, I've been kind of out of it lately. Did a whole bunch of stuff on algorithms last week, and now I'm just trying to get back into the swing of things. I think that really the main thing was just the amount of mental effort that went into the generalized advantage estimation work on the theory side. Not even really theory, it's not even that hard of math, but it was a little bit unintuitive. I think I have something, though, that will work. So really my goal for today is just to get something implemented there. And I'm hoping that we can get something training. I'm hoping we can get something training. Is the X streaming working again? It is. Great. All right, that still works. Okay, so we are on the right branch. And I think that all I wanted to do was normalize here. Yeah. I'm going to make gamma sum. I thought about this for a little while off stream. Actually, it's not even gamma sum, it's gamma max that I wanted to normalize by. This was the key. And so we'll just do if gamma is greater than gamma max, we update gamma max. I've been busy. It's not even as much as I've been busy, as much as just last week was pretty mentally taxing with the type of work that I was doing here. That's mainly just been it. You know when you're like really out of it and your brain just won't do what you want? Yeah. But I think that I'm good enough here to at least get in enough to finish this algorithm, and then we'll be able to move on to other stuff. Like your tweet from hours ago? Which one? The anthropic one or the other stuff? I don't know what it is where like, oh yeah, I don't know what it is with these labs, right? They have all these technical people doing awesome work, and then like for absolutely no reason whatsoever, like the CEOs just decide to be total scumbags and lie about everything. I mean, hell, even the name of the fucking company, it's not Anthropic AI. It's not. You guys are contracting with Palantir for defense tech, which is fine. Defense is good, but don't call yourself Anthropic and say we're gonna be a city on the hill for how people should do AI development. Like, fuck off. They want the Manhattan Project contract, and I don't trust them with it because they lie and they virtue signal and they say that they're holier than thou, and they're not. Right? There's almost nobody I trust less than a highly ethical SF tech bro. They can't stop. Yeah, exactly. And if they try, we will fight back. Okay. This is a little tricky here because this requires. I think this requires 2 passes, doesn't it? That sucks. Okay. I don't use this yet, do I? Go here. Go gamma. The thing is, I don't want to be fighting them either. Like, I would like them to just fuck off and let me do my stuff. Right? Might be moving to Austin. My friend doesn't get a new role after the reorg. 400k capital to get going. Bring around 200k if it goes well. Postdoc is not worth it if he can join the team. Awesome. Best of luck with that. That sounds great. I haven't ever been to Austin, I don't think. Texas is cool. I don't think I've been to Austin. More, that's what you're looking at, Captain. I want to actually make some progress here. I don't want to just dick around and like keep being confused though. Ward mask can go here. Potential for future collab if it happens. Great. Really career minded. Called me 2 days ago. Awesome. Well, I mean, good luck with that, right? You let me know when you need RL stuff. If it's promising, right? Puffer takes for startups. Puffer takes equity over cash, so you can get some help on stuff without having to burn any runway. But that's only if you actually have an RL problem set up that I think is like reasonable, right? I'm not gonna waste your time on stuff if there's not like a clear-cut RL setup. Wait, what? I haven't gotten an email back. Oh, good. Yeah, we discussed that. Yep, I know. I'm just bringing it up. Favorable in all situation. Easier to jump out of that. Yeah, just make sure they're actually on for the ride, right? I had a whole course at MIT that was literally just dealing with co-founder bullshit. And I was like, you know what? I think I'm happier doing this shit solo anyways. But that's me. A lot of people do very well co-founded, and it makes it easier to raise capital. Much easier to raise capital with multiple people on board. I don't know why. It's kind of funny it works that way. But I wasn't going that route anyways. Raising capital kind of sucks. you know? And the only thing we have to do here is why does my autocomplete not work? Okay. Hello, hello, welcome. We're working on the advantage kernel for the new algorithm right now. I think I figured out a really simple way to deal with the normalization crap that was messing with me. We're just going to divide gamma by the maximum gamma, and we're going to hope that works. Go to Chevron, in school. They'd be sad to lose him. Hope they do for my sake. Jeez. Why? You know, if you piss off your people, right? Big companies are just a rough place to work a lot of the time, as far as I'm concerned. It's like stable, but that's about it. Finally fixed a small bug in Impulse Force that's been plaguing me for a month. Made a few more small tweaks. Really fun to play, even against scripted agents. Awesome. Hey, looks like there'll be a PR on that soon. Working at smaller places much more, yeah. I don't think I've ever been more depressed than when I was like at Amazon for a summer. And it wasn't the fault of, the guy that brought me on. He was actually like trying to make progress. There were a few other people that were trying to make progress. But then there were just like a ton of people who were just like shipping thousands of lines of garbage code that you'd have to deal with and were like clear cut 9 to 5ers where it's like they never wanted to do any extra work on anything to make something actually functional. They'd like get mad if you off-railed their like very bureaucratic worthless meeting to try to like discuss a new way of doing stuff. It was just like, I never want to deal with these type of people again, right? This is a waste of my time. Way more interesting to be working with people who give a shit. Best of luck with the defense. We don't need this norm anymore. Looks better. That PPO advantage normalization, advantage normalization. This is P30 advantage normalization. This is the new algorithm that I'm working on. I think this makes sense. Was it 32? So where does it get this reward from, though, is the question. Ah. Something is screwy here. Rewards t to t plus 1. I don't understand how this has non-zero reward when the rewards here are not like this. That's a little odd. I want to make sure we have this kernel implemented correctly and then actually properly test it today, instead of like fiddling around with stuff that's probably half wrong. Yeah, under no circumstance should this be able to be positive, right? Oh, hang on, wait. No, buff has reward R, which is gamma times R. R is rewards t plus 1, which should be 0. Done's, there's nothing is done. Okay, so this is very odd. Why would it be like this? Kernel, this is a CUDA kernel. .cu. Isn't that what you call them? Anything in CUDA? For like just a little math op, it's a CUDA kernel, right? We're jamming some CUDA. Oh yeah. Hey, hey, Captain, you might have. This might be a little crazy, but I think I came up with a way to run a lot of our environments in CUDA without changing the code. So, without rewriting it at least. So this is a crazy idea, right? This is honestly like I think it's kind of genius, but this is just C, right? And it just has an index operation where it just gives it the index on which to run the code. Okay? So we'll just make this index the index of the current environment and then just call the environment code. And then it'll be CUDA parallel, right, with each CUDA core on a different environment instead of running them serially on the same core on the CPU. It's pretty funny, right? Like, doesn't that actually kind of work? So I think it would be pretty funny if after all this time of writing all these M's, right, we actually came up with a way to just run them in CUDA for the hell of it. uh, so I might play with that at some point when I next get some time. Because sometimes, I don't know, this is like just something that occurred to me while I was running. I was like, we're going to run the environments on CUDA and we're going to call it Barracuda. You just compile it with CUDA compiler? Yup. It's kind of funny, isn't it? I get cool ideas every once in a while. Usually I don't have that many good ideas, but every once in a while. Uh, I just think it would be hilarious to just like, well, the Jax people just runs on the GPU and then there's no overhead of the transfer. It's like, okay, we changed the compile settings and now we run on GPU and our code seems easier to read. GPU would be doing everything. Yeah, so the idea would be it would have to be so fast, right? That like you don't even notice the overhead. But I just think it would be funny regardless. And also it would kind of like open it up a little bit for us, right? Like let's say we wanted to really do some heavy physics environments, right? We could just write the whole thing in C, and then maybe some little things need to run in CUDA, who knows? Or maybe we just like, whatever. We prototype it on the CPU and then we just paste it to the GPU and it's fast. Right? I mean, CUDA's just C. Like, look at this. This is C. You could paste the same code into C with just this index and it would run. It's a Would it speed up impulse wars? Maybe. Maybe. I mean, I wouldn't go into this for impulse wars initially, right? I would try this on something silly. But it's a possibility. Main thing I want to do is I want to get you finished up with impulse wars so you can help me on research side stuff. Because I need help on research and I need to train some more researchers to help me. Yeah. It's kind of cool to see like how quickly people are learning through PufferLib, how quickly people are getting good at Puffer stuff. Like, I mean, Spencer's been what here for several months, maybe like at this point, and honestly, like dev side, I think he can already do more in RL like than the vast majority of PhDs. So if you come in with strong programming background, I'm sure you'll be the same. I just haven't reviewed your code yet to be able to make that assertion, right? But yeah, pretty much if you just come into RL with a strong programming background and you really do the low level stuff and then you kind of like onboard the rest of it, you're really already doing more than the majority of people. All right, what I gotta focus up on this. What is wrong here? Like seriously? Do I bite the bullet and just write a test? The only thing is I don't know how do you write a test for this when it's running through PyTorch? Can I run this without PyBind? What do you think of Impulse Wars? Long review? Yeah, that's fine. Hey, if you put the effort into to write a long environment, I do a long review. See shortcuts in simulating the physics. Yeah, so that's where we need. That's tough because there you need people who are like really good low-level programmers and good at physics. Like I probably wouldn't be able to see how to do that because I don't understand the physics. That's the tough bit. I mean, physics at the level of robotics, yeah, I might be able to see some shortcuts. But like physics, no, that's harder. I think we have to write a test for this. Since I don't know how to write a test for this, I am going to leverage, I'm going to get Grok to do a little bit, but then I'm going to clean it up substantially. I really don't like doing this type of thing at all. Let's see, do we have people yelling at me? No, I have people yelling at the people yelling at me. Great. How to get good at low level? Just do it. Write some M's in Puffer. The stuff we're doing in Puffer is really not that complicated. Like, honestly, like compared to like some like really close embedded system stuff, like close to hardware embedded system stuff, we're really just doing basic C, keeping it very simple, and integrating stuff nicely with the rest of our RL tools. It's not that hard. It's really not that hard, I promise you. To give you an idea, though, of how easy it is, I wrote Python for 10 years and I was comfortable in C in 3 weeks. How to get started? Literally just like build a little env. Look, here. This is the simplest possible demo I can give you, right? We have from very simple to very complex, right? Ocean, here, squared. Very basic little env. Squared.h. Okay, here's some boilerplate that does memory allocations. Here's the logic. That's it. What do you need to be able to do this, right? You need to know the difference between a value and a reference. That's just what a pointer is, right? You need to be able to write if statements and maybe write some loops. That's it. Like any first year undergrad who has taken like their first systems course can do this if they actually bother to like try. Okay, and then from here, you go on to something like Pong. I don't know how clean the Pong code is, to be fair. Maybe Snake is better. I did Snake. Okay, 300 lines. There's some logging. Here's the code. What does it have? A few loops, some conditionals, single pointers. That's it. Snake is so good for multi-agent inspiration. Yeah, I hope it is. And I think I cleaned this code a little bit up since I wrote it, but I basically wrote this after having been programming in C for a couple of weeks. It's not hard. It's really not hard. You just have to actually try. Like, you just have to start. You just have to set aside some time. You have to care enough to actually, put in the effort to learn and, like, understand that it is a good thing to go lower level. For a long time, that was the mental block for me, is I didn't want to get lower level because I associated it with, like, buggier code, slower pace of development, right? And it's literally just skill issue. Like, that's just straight skill issue. Like, as soon as you start doing it, and then you learn a little bit, you realize, like, oh, I can compile my code with fsanitize. Then I don't get seg faults. I get reasonable error messages. Oh no, I have to think about memory allocation and deallocation. Oh wait, that's really, really easy. You do your allocations, you run your code, you delete the allocations. That's it. Okay? Oh, I have to think about pointers. It's just a reference. Okay? Oh, but double pointers are hard. Like, I have to think about multiple layers of indirection. Don't use them. 1D indexing is so hard. It's like you don't have like multiple sliced syntax. Okay? You make a little function, x, y, width times x plus y, or whatever, width times y plus x, there. That's your 1D indexing, done. That's it. There's nothing else hard here. It's just like we've put stuff up on so much of a pedestal that we make stuff hard. Okay. I hate how it's written this test. CUDA check. CUDA malloc. I think what I'm going to do is instead of having this clean it up, I'm going to clean it up manually so that I learn more. Our LLM's good, so I can maybe get started. Yes, but I don't suggest that you have them just generate your code for you, because they generate crappy code and you don't learn much that way. Like, what I suggest you do instead is you start with one of the reference projects, so copy that as a template, go through and understand it, try to build your environment from there, and then use the LLM as docs, like ask it questions when you're confused. As I paste in a giant block of code, but I'm about to clean this crap up because this code sucks. I might at least run it first, though. It also depends on your programming background, right? Like, did you do, well, I don't know where you are in life, right? But if you did an undergraduate course in C, ever, at one point, you know enough. Just go through squared and try to understand what it is, what, and how. Yeah. I mean, really the only concepts like, do you know what a pointer is? Yeah, rebuild it. Like, you can make your own little env, right? It comes with rendering. It's really easy to hack on. You learn from there. The only, like, you should know what a pointer is, right? You should know basic programming, loops and conditionals. You should know what a struct is. Like, I don't know your background, right? But, like, the prereqs are very low. The bar is very, very low. Only thing I'm not familiar with is memalloc. Okay, you need a piece of memory. You need some number of bytes of memory. So you call malloc of that many bytes, and now you have memory. You just get a pointer, you just get the address and memory of where you're going to write your data. It shows you in the example as well how I've done that, because we don't do that at all once you've made the environment. You allocate the memory that you need for your environment, you run your environment using that memory, and then you just clean it up at the end. That's it. Lodestar star. Oh, that is so funny. Look at that. It literally can't even do this basic test right. That work? Passing incompatible pointer type in definition of macro. I don't know why it made this macro anyways. It's a useless macro. We'll do this one here. Hello, how are things today? They're going. We're working on some stuff. What does Kuda Malik take? Kuda Malik. Neural nets, how I did copy squared, zero expansion C, read basic stuff, yep. I generally suggest that new people learning stuff, like you spend 80% of your time building, you spend 20% of your time seeking out and learning from formal resources. So it is a void star star. Dev pointer. Pointer to allocated device memory. Okay. Explain Kuda Malik. Why does it take void star? Just change Malik? No, we wouldn't, would we? I think all we would do is just like, we malloc in the init, right? You just change those to CUDA mallocs, and I think you're done. So you just make a CUDA version of the init function. It's like a tiny amount of code. Memory with the dev pointer. I don't know what this is. I've never used this. Will be set. Common C idiom. Let me see. It's analogous to malloc. Malloc is GPU memory. A pointer to a pointer that will be set to the address of the allocated device memory. If you want a void star, pass in void star star so the function can set. I don't know why it doesn't just give me a pointer back. Function arguments are passed by value. CUDA malloc were designed to take a void star. Well, that's not what I asked, dummy. Why would it need a void star in the first place? Is this thing gaslighting me? Like, I don't want... Okay, this takes size T. Oh, I see, because they don't want to return the pointer. That's obnoxious. I thought you can just check the value of the pointer, though, if it doesn't give you a proper pointer. No, I don't want to wrap it. I want to understand what the heck this is. Okay, so you just give it... Okay, so you just make the pointer. Yeah, that's not bad, though, because you don't actually deal with the double pointer. You just give it the address of the pointer, and the pointer's populated for you. Okay. And then oh, does it want this? Before the ampersand. Yes, yes, that was done. Wait, no, because it's not that. It's then you have to do void star star. Can you even cast that way? Is that even a valid cast? Guess it is. Okay. I wouldn't think that would be a valid cast because that's a float star star to a void star. I didn't know you could do that. A double cast like that. That's kind of gross though. I don't like being made to deal with double pointers for no reason. Well, this isn't C being gross, right? This is specifically Kuda Malik being gross. That's not on C. Well, yeah, but like every language has a bunch of stupid APIs, right? What's this? What the hell is this triple? What's this? CUDA kernel syntax. Standard for C. How many thread blocks? Okay. So this can't be in a .c. So this has to be a .cu. What are your thoughts on the Alberta plan? Haven't seen it. Let me use the restroom real quick. I'll be right back. All right. Undefined reference to. Did I get the signature wrong? Word block, mask, values, mean, and standard deviation. Buff, done, rewards, advantages, bounds. Steps, probably the inclusion is wrong. Include advantage.cu. Try this. Ah. Okay. How do you do that then? I guess you have to separate. What you do is sand that Sutton helped develop. I'd have to read it. Obviously, I give Sutton tremendous credit for his contributions in the earlier days of RL. I don't know about his latest research directions and what he's doing. So I'd have to look. PR from a branch, merge into local fork. What are you PRing? It depends what you're PRing. If you're PRing like a critical bug fix or something that needs to be in main immediately, then it goes to 2.0. But if you're PRing a new end, yeah, it should probably go into dev. I mean, if you have something that you want to be like immediately included into main that's like stable and doesn't have any weird build issues and stuff like that, then I can try to get it into main faster. But if there are any like questions about stuff, and maybe needing a little bit more work, then it goes to dev. Yeah, Brad, I'd have to look at it, and I really want to get this done right now. So I think like chatting about whatever else is on in here is about the most. I'm not gonna like just go read this right now. Might need more work, yeah. Then just go to dev. Go to dev. I generally suggest new people like try to try to come up with like simple environments that are an interesting learning problem in some way. I don't know if this is an environment that I gave you the idea for, if you're just coming up with one on your own, but either way. Just dev. Yeah, I have everything in just dev right now. I need to do a big cleanup of a lot of the branches at some point soon. Okay, so I think that this is how we do this, right? So we do PufferLib.cu. Okay. And then we go here. We grab the PyBind. We paste this. We get rid of this. Global void advantage kernel. What do we think about that? And then I think that'll do it. Put a check. So now we can do our tests and our torch separately, and we have a nice PufferLib file to import everything from. I'm probably missing something about why this check was there in the first place, but I didn't like that it made a macro anyways. Okay, so lovely. So look at that. Now we can Now we can do this. Num step will be 16. What was it? 32 step. Horizon is 16 step with a horizon of 8 is good. We use values mean here. It's kind of silly that we pass value mean, isn't it? Be a little lazy here. I think you can do, if I do this, I can use this for static allocation, can't I? Particularly if I put these up top. Okay, great. Advantages. 4, and then horizon is 6. I can do. Okay, and now we have values, standard deviation. Going through Bardo and Sutton book, I think C and Ocean M's would be nice to have. I gotta be honest with you, I've never read that book. I probably should have. And at some point, I will probably get bitten and have to go back and, like, I don't know, do a retreat for a month in which I just try to actually understand RL math. But if you're trying to get into RL and you're trying to get some stuff to work quickly, then there is much more math in that book than you need to be productive. If you like coming at things from a math angle, then it's a perfectly good resource. If you want a more engineering-oriented reference that still references like good lit to learn from, I would suggest my quick start guide. Six steps. 3. Issues when merging with dev branch. I try to run the demo file with my env. I get an arrow. Comes from the Pyro module. Pip install. Oh, that's annoying. I don't know why you would get an install error on that. So Pyro is Gaussian. It's used for Gaussian processes, and we need it in our new sweeps library. Do you have like a really old version of Torch or something? Because Pyro should just be a pip install. I think that should be fine. I assume you don't mean 3.1. I assume you mean 3.10 or 3.11 or something. I don't know why that would crash. You're free to comment it out though. 310. You're free to just comment out that it's only used in one place in sweeps. So you're free to just comment it out. Pip name isn't Pyro. Pyro PPL. Okay. Yeah, careful. People name squat packages, and some of them are malicious. People will like put malware into packages with similar names to common packages. So you got to be a little careful guessing. Yeah, there you go. There you go. Okay, lovely. Now we have this test set up, and we just have to figure out what's wrong with it. But look how clean this is. Now, can I run this with CUDA GDB is the question. I can. Oh, that's awesome. No module C advantage. Any.cu. Yeah, but again, just comment it, okay? There's a reason that the dev branch is a dev branch, right? It's because I'm adding and changing stuff in it constantly. So all you have to do is find like you're allowed to just comment shit out. All you have to do, and just don't add the comments to your PR, right? All you have to do is make sure that the env works on like some version minus whatever stuff I'm working on, and I'll merge it in. No, no worries. Like this is just me hacking on stuff, right? Like yeah, that CUDA module absolutely doesn't need to be imported at the top of the file, right? And there should be a fallback. I just haven't done it yet. Why did that not run? Can you can set breakpoints, right? Why does it not hit my breakpoint? Why does it not give me? How do I set breakpoints in this thing? Ah, missing flag. If I comment, then the end won't train. No, the requirement is just to make sure that the env works correctly. But if it won't train, then the env. Wait, why won't it train? It should. I think the that dot like that. So that CUDA function should only be required for P3O, which is not the default. So I think it should train with PPO still. Clean PufferL. Does did the environment train before on your setup though? Like, did you get the environment training on your setup? Oh, what can you remind me what environment this is? That's fine. Multi-grid agents need to manage food and not deplete. Okay, cool. Food and not depleted. Yeah, that's fine. You can PR that. Ah, that's why. That's so cool. We have debugging through CUDA now. So basically, CUDA is just C. We just write C, you compile it a little differently, that's it. Same debugger as before, pretty much. And things are just easy. That's really nice. I mean, that was the one annoying thing before, is just not having the debugger, right? And it's the thing that sucks about Python, is not really having a good debugger. This is clean. Many abilities. But the thing is, it's like not even hard, it's just easy. Did I not recompile? There we go. So we'll figure out why it just worked this way. I don't know, I think like C and CUDA are like these super scary things to a lot of people. I thought CUDA was gonna be way worse than this. But like this is really chill. This is just easy. It's like, yeah, the hardcore CUDA engine. Come on. You're writing C. You're writing C and then thinking, maybe you're thinking, over parallelism in multiple dimensions or blocks or whatever. Who cares? Yeah, you might be solving hard problems with it, but like the language isn't hard. All right. Mm-hmm. K minus 2. Can probably use conditional compilation to make Ocean M's build. I don't know why you would do that though, right? Why would you do that when you can just define two different init methods or whatever, right? And you can just use the CUDA method, like the CUDA init method in the CUDA version. Then you don't even need conditional stuff. Isn't that just easier? Yeah, but like you would just make like I did with the test file, right? So in the test file, you just make CUDA init, and you just when you initialize your environment, you just use that one instead of regular init, right? You have to play with it, of course, but it doesn't seem that bad. I am thinking about the Cython layer though, and I'm not happy about that Cython layer at all. I'd make a malloc macro. Um, I think you could do the same thing with a function, and then yes. I'd say do it with a function, not a macro. Oh wait, does it have to be defined? Yeah. I might have to look at that. Macros just get. I do not like macros. I'm not a macros enjoyer. Yeah, I just found a bug with this debugger that I wouldn't have never found that bug. I will see the necessity when I get there. The heck? Am I going crazy? Why is it not int j equal k minus 1? 58. Because you didn't recompile it, stupid. There we go. Lovely. Now we actually get to see what is useful. We can ensure that our kernel actually gives us the advantage that we like. And then without changing the code, we should just be able to have this bound to PyTorch with PufferLib.cu, just like this. Just imports this separately, adds the torch dependency, right? And that should work. Let me see if I like the way that it's done the reward computation. So we do 1, 2, 3, 4. Yeah, so it's offset by 1, right? Hang on, how did it get 2? Wait, 1, 1, and then 2. That doesn't make sense. Plus equal gamma times r. Okay. So t starts at 2. We get a gamma of 1, reward of 1. Reward is 0. Gamma is 0.5 times r. Okay, r remains 1. T is now 0. R is 1. Did I forget something here? Oh, you do have a second reward here, silly. Yeah, you're good. Okay, so you go one step before this is 1, and then another step. You see the reward 1 ahead, right? So you see the reward here. You get 1, and then you have 1, and then you see the reward here, and you get 2, so you have 2. Okay. And then the second one, you get 1 and 1. Yeah, because you start on this step. Then you get 1 and zeros. And then if you keep going a little bit, you get this one here. Hang on. You start here. Oh, I think I do have another error here, right? No, wait, if I'm done, I grab the reward from the next time step. Right? Or no? No, if you're done, you grab the reward from this time step. How do I have it right now? Duns of T. T plus 1 here. No. So we'll have to figure out this indexing. But this is so much easier now. Having a debugger, this no longer feels painful. This process, this whole thing felt like very annoying and painful without the debugger, and now it feels just like, I mean, I could just be writing normal C, right? I could just, be writing not CUDA, and it's the same thing. So this is great. Be right back, give me a second, and then we will finish debugging this thing, and we'll make some decisions, and we'll be able to actually run experiments. Oh, this is great. Right back. Whew. Let's figure out the actual indexing that we need to do here. When you get a done signal, that is the same step you get the last reward on, right? Believe so. I do this now. Okay, that changed how this looks. Yeah. I think this looks good to me. So 211, that's a correct sum. And then you lose the last reward, right? So you just get, hang on, how do you lose the last reward? No, you don't lose the last reward. You lose the first reward. Yes, you lose the first reward and you get 1 and 1, and then you go ahead a step and then you get 1. And then you go ahead a step and then you hit the episode bound and you get 1 and 1, and then you go ahead 1, you get 1, and then you hit the end of the episode, all the episodes. This is correct. Great. This is hopefully a correct kernel. So advantage kernel, PufferLib.cu. That's PPO. That would be a little too much to hope for that it works instantly, right? Is it reward block? No, it's just rewards. Perfect. And this one's offset one further back. So this is perfect. Yep, this is absolutely perfect. Whoop. Legal memory access. Okay. Where could we have messed up? Is it in the buffers? I don't think so. Uh, hmm. Is there a way to see where the illegal access is? Oh, here. Let me just try one thing real quick. Oh no, I don't have done here at the end. I was thinking like, hey, maybe if there's a done at the end, it's like capping it. But this should be fine. Zero, you divide. I check everywhere I have a division, don't I? But it says illegal memory access. That won't change anything. So you go up to I'm not seeing where this would be an illegal access. Synchronize. Yeah, it's right after this as well, isn't it? Okay. Maybe if can I trigger a recompile? Oops. Hey, welcome. This did not get us any better information, did it? Can I pass this to the compile flag or something? Hang on. Port check. Is that going to get us the error? Yeah, that's just going to say whether it's in which kernel, whether it's what level it's at. Exact line, okay. Hang on. Can we do CUDA mem check? Is removed and has been replaced with compute sanitizer. How do you run this? Compute sanitizer. Oh, this is here. Okay. What? But how do I run? How do I run this with Python? Worst part of CUDA how to get it, how to run. It's actually only because I'm running it through PyTorch, and I don't get the error without running it through PyTorch. This has been actually really nice. So this is the CUDA kernel here, and we have this test right here, and this works. We caught several bugs with this, and then here's the binding, just the PyBind. Now the only thing that's wrong here is I get an error running through Torch that's not caught by the test, and I want the trace, right? Like I basically want to just compile it with a sanitizer, and I can't figure out how to do that. You shouldn't need to include this in the extension. Can I just do it like this? I don't know if this will work because I don't think you have symbols here. Oh geez, and now this is running the compute sanitizer on everything. Which is not what we want. What do we only apply compute sanitizer on kernel? Everything. Unspecified launch failure. So it is potentially in launch. Okay. Contiguous. Reward block mean standard deviation buff done for rewards. Is bounds. I don't see why that wouldn't be contiguous. Right? Yeah, that's very obnoxious. Unspecified launch failure. PyBind would catch like wrong type stuff, wouldn't it? Maybe one of them comes off the GPU somehow? Nope. Not as far as I can see. Threads per block, block. See, I don't see how this could possibly be a launch error though. Right? Like how could this possibly be a launch error? Like if I just return here, yeah, you see that's fine. I wonder if this does it. Kernel name. Oh, hang on, this just might be kernel. I thought I had it. You can pass kernel name, it says, right? Anybody know what I'm doing wrong? I gotta be doing something stupid here, right? I don't see anything though. So it just gaslights you, huh? A useless bot. Right here, kernel name. Key equals value. Oh, that's annoying. Error building. Did I mess something up here? So now it fails to build. So weird. Debugging definitely needs to be better here. And to be clear, it builds without this, right? Is there still a filter? Valid values for keys. Kernel name. Kernel substring. Still no? So I don't even know if this is a build error with running this through Torch or what. So that's obnoxious. I mean, I could just try to find it. I think longer term, though, I'm going to want better debugging tools in this. Okay, so less than horizon, right? J++. 31. So this could be 31. And then wrote.h file for squared. What do you mean you wrote the .h file for squared? There is a .h file for squared, right? I mean, did you do something based on it, or ocean squared, right? .c to .pi. What about pi x? Oh, I think, okay, you're trying to learn this stuff. So, if you just look at the, I mean, either in 2.0 or dev, it's the same thing. If you just look at the squared directory, right, you'll see how we do all the bindings for everything. So here's the Python file we're currently using as the intermediary. It's a short little file, and it just defines the intermediate functions as well as the loop over multiple copies. Hang on, I think I'm still off by 1 here. Right? Because if this goes up to 31, is this supposed to be -2? Let's say I put a 2 here. So we write in this manner, right? Yeah, it's meant to be an example, right? So like all that squared is, it's a really simple environment to use as an example to get yourself familiar with the process of writing efficient environment code and then binding it to Python so you can actually use it for RL, right? So we have the .c file. You can just run this whole thing in pure C. This is nice for development, and we also use it for demos, right? You have the .h, which has the actual logic, everything in C. The Python file, which is just essentially the binding layer. And then finally, you get to see how you use it in, oops, not this one. You get to see how you use it in Python. And I mean, we have examples like this for everything. I mean, all the different environments serve as examples. So if you like write something based on squared, you get comfortable, then you can look at something like snake for a slightly more complex example. It's only like, I don't know, 300 some odd lines of code, and a lot of it's just the logging that we add in. And here's the env code, right? Here's the code for computing observations, removing snakes, adding snakes, creating food. Here's the reset function. Here's the game logic. 100 lines, and there you go. Oh, did I still get a legal memory address? I still get a legal memory address. That's weird. Really? Steps -2 is still 30. Thanks. Yeah, no worries. less than horizon. Is it -1 here? Hang on. Let's see if that fixes it. Okay, I'm very confused as to how this can actually be being wrong at this point. I'm gonna set it to, I'm just gonna make absolutely sure that it's not an off by 1 or 2. I don't think this should be -2 here, to be clear. Okay, yeah, no. Python hasn't rotted my brain, right? This loops to 0. Equal to 0. Okay, no, I'm not. This goes to 30. T is greater than num steps -2. So that's 30. Yeah, this is all fine. And yeah, this works as before. Yeah, well, this is fiddly. There's not a good way of debugging this as far as I'm aware. Bizarre. Very bizarre. Why not comment all the array assignments? To be fair, I did something before, but yeah, that would be a really good way of narrowing it down. I'm kind of just getting stupid here. Yeah. Oh, missed one. Because I don't even know where, like, I don't even have any idea where this is. It's really annoying that you can't just, like, set a flag to get memory sanitizer working. The heck? Now it fails to build? Really? Oh, hold on. Yeah, if this works, we should just be able to binary search it, right? I hate having to debug code this way, though. It's like so incredibly boring. I just lose all focus. As long as I have a working debugger, I can usually make progress very, very quickly. This type of shit is just really annoying. Particularly because this worked on my this worked on the test. Okay, so this doesn't fail. At least without, the thing is the score distribution changes as well, right? We'll see. Yeah, we'll just take a few minutes, binary search it. Okay, how is this still freaking broken? Word. Oops. Yeah, it's painful. I mean, I genuinely really enjoy my work when it's not like this, right? Because as long as I have the feedback loop, I can build stuff very, very quickly. Okay, legal memory access. When you have this on, so is the bug on the T index then? If the IDX index is correct? Oh, hang on. T plus 1. How do you do this? T plus 1. I plus J. Do I just have this index totally wrong? I times horizon plus J. No. So it's this T, it's the T plus 1 index that's out of bounds, but how is that out of bounds? I plus J plus 1. Block index times block dim plus thread index. I mean, that's just giving you the offset that it processes, right? that it processes. Thread index. Hold on, what if, so if k equals 0, is there like an edge case on the very last one? K minus 1. No. I actually don't know what's wrong with that index. Let me try that. Hang on, compiler might optimize that out. Did this break? Yeah, this broke. There. What's the plan for neural MMO? Still think it's the best way? Well, have you seen 3.0? I built this I built this over the summer. So this is pretty much everything I did during my PhD on neural MMO, except it looks better and it runs 1,000 times faster. And it actually has a few additional tricky bits fixed as well. And this is, I mean, it's bigger. This is actually even not the full-size map. This is just what we run on the web version. More agents. So yeah, there is a lot of stuff for neural MMO going forward. And in fact, it's going to be a core end in a lot of the research that we're doing. It's just that there's so many things that are broken with reinforcement learning that, you know, the thing of Puffer is more general. It's we got to fix reinforcement learning. Like, I started neural MMO as a project of like, how do we push reinforcement learning to really solve long-term challenges in AI? And then it's like, you know, we fell off the bike and broke both our legs because we had like nobody's ever solved any of the really, really basic, obvious stuff. Haven't seen this actually. It's awesome. It's all open source. And in fact, it's like a third of the length of the code as Neural MMO 2 is as well. It was the first thing I wrote in C, so there are a couple little things on this that are weird, but yeah. 2,800 some odd lines. It's all right here, this one file. I think a first-year undergrad could scroll through this and read it as well. It's very, very simple code, with the exception of a couple PCG algorithms, and then the way I select tiles for rendering is a little janky, but everything else is pretty simple. I mean, we have more than just this as well, right? We've got like miniature version of OpenAI 5 here. Now, I can play this, and where's like something? Oops. Am I holding the wrong key? Yeah, I'm holding the wrong key. But anyways, you can play around with some of those on the website. There's a lot to do. Okay, so we still get an illegal memory access. The model on the website is not great, but it is kind of a cool demo in the sense that I trained the model for over 2,000 years of gameplay, and you can just do that now because it runs so fast. Definitely gonna take a look at those. I've seen the MOBA, but somehow missed Neural MMO 3. There's a blog post as well on it. I think it's just on my X. Yeah. That's the big world. Items, combat and progression, trading, economy. There's a baseline model. There's some stuff. Aha, this fixes it. So the question is, why is T this big? Oh, I think I see it. And we'll have to fix something with that because that'll change something else, but we'll see. It's so fiddly that you can't like catch that. Funny thing is, I could make Neural MMO so much better, going forward as well. It really was just like I just started coding that thing, like manic coding in Python, and like I made a whole bunch of dumb design decisions because I was using Python instead of C from the start, and then I just basically did a one-to-one port into C and cleaned it up a little bit. Um, so yeah, I could probably make it even better. It's not the type of thing where I think that the best use of my time is to just always work on Neural MMO and nothing else, right? There's like core stuff in RL to fix that is, I mean, you can fix it on much simpler M's and then have it work on Neural MMO and more complex M's. But I think it is going to be a project that I keep coming back to as like, the hard M to test on. Okay, so this still works. There we go. See if this still works. Sorry for the interrogation. No, you're good. You're good. Got super bogged down with this. Let's see if it works now. God damn, still? Ugh. Fascinated by complex environments that potentially approach open-endedness. Yeah, and I mean, we've had a few good candidates, but the main problems have been infra. Like NetHack, for instance. NetHack is really awesome. It is single agent, which is a little limiting, but it's like a really, really hard env. Well, the problem with it is the Python wrappers are kind of slow, and the environment itself, apparently you can't run multiple copies per process. There's like an issue with threading it. I mean, not threading it. There's like an issue with it having global variables or whatever. So you can't batch it in the way that you'd actually want for RL. And like, I mean, the number of people that understand like that is an issue, and like that is the main thing holding it back is single digit to non-existent, right? Like people just see environment, they see oh it looks hard, they see oh people didn't make much progress on it, RL must not just work very well, right? They don't see like well it's mostly researchers with tiny hardware budgets, and the env is just running too slow because of these constraints, right? So that's what we're trying to fix. This got way farther though, didn't it? No, it only got to 10 mil. It's weird. RL Iceberg video explains that. Yeah. Oh, I guess more than 0 people know that now with the video. um, but the thing that's just so sad about this is like, I really didn't have to bust out anything too crazy to make this work, right? Like, it's not like I have some fancy new SIMD architecture for specifically for RLMs. Like, no, I just wrote really, really basic, simple C. That's all I did. I just wrote not Python and like not stupid. That's it. I mean, that's kind of sad, right? Okay, this is gonna drive me nuts. How is this still broken? T plus 1. Big on a ton of topics, so I have more to read on today. What are your general thoughts on volunteer computing applied to these environments? Um, I mean, generally the way it works at the moment is like the M's are fast enough that if you have a decent desktop, you can do some research with us. And if you are a prominent contributor, then I get you hardware access anyways. We don't have a ton at the moment. We just have like a very small cluster, but we do have plans and funds to get a 40 node cluster, so we can be farming out more resources to contributors. That's really the plan here. And I mean, we have this at the moment. So we're going to end up with 40 of these. And we have a new facility that's going to be able to take care of these. And, I'll have some of those boxes for myself. I'll allocate a bunch of them to open source contributors. And then we will use some of them for work done for clients. That's the current plan. Holding it home. Um, I don't know if it's the same type of problem where it just automatically scales that well. It's more like we run batches of like a couple hundred experiments at a time. I think we're going to be okay on compute is the thing. Because, like, unless something changes, our stuff just runs fast enough that I can just have the compute cluster for this and just make it easy, right? Like, I think we only need on the order of like a few $100,000 worth of compute. So I can just do that. And then that's just taken care of. What is wrong with this? Oh, hang on. So you do. That works. I wonder if this will do it. I don't know. I'm kind of getting tired of debugging stupid indexing bugs. Dude, seriously, how is this still a problem? How? Maybe if it gets to the end here, is this the problem? Drive me nuts. Maybe I just overcount by 1. This loops horizon times. I think maybe I just overcount by 1. So all the indexing wasn't mattering because I just overcounted the K was 1 too large. No? Still no? Screw you. Really? So obnoxious. No, this should be fine as well. This should literally be fine. This is the type of shit I hate doing, because it's like I could be getting so much stuff done. Mm. The largest that this can get is horizon -1, right? 31. Okay. Plus 32. That seems bad. Right. And then it fails there because and this breaks, right? Might have time to look at solving this. I'm hoping I solved this before today. I mean, that would be ridiculous if not. Right. I'm kind of just trying stuff at this point. Any interest in that? Is that too deep in the code base? I mean, if you have CUDA experience, you're welcome to, but like this is like one silly little fiddly kernel in a new algorithm that doesn't make much sense yet. So yeah. Let me finish probably let me finish this. I think we're probably gonna start doing some more CUDA somewhat soon. But then there's tons of cool stuff on the environment side. And for people with more research background, there's tons of science side stuff. There's tons of experiment side stuff. There's just lots and lots and lots of things to do in Puffer right now. Does this run? Looks like it runs. Maybe I fixed it. Yeah. Yay. Okay, so it doesn't train, but we will look at that. We will look at that, right? Oops. Oh yeah, there's data in there. There we go, there's something. Here's your reward of 1, 6, 7, 6. Perfect. Because it's 6 before this. And you get your gamma. So now why are these not 1s? Gamma max. Why are these not 1s? Gamma max times reward. Oh, is it the value standard deviations are different? Yeah, the value standard deviations are different, right? Well, they're not really, though. They're very close. So why would this happen then? Okay, cool. Okay, here's a good example. Yes, this matches up. Here are your gammas. Gamma is divided by gamma max. Hang on, how is this possible? It's more confident towards the end. Well, that's weird. That could just be some drift, though it does seem pretty consistent. Oh, you know what this is? I think this is just my initialization. Okay. Here's a tiny one. Oh, and this doesn't make sense either, right? There are two sets of rewards there. No duns. Oh, it just printed weird. Yeah, no, this is correct. That it has this. And why is this value so low? That doesn't make sense to me. Maybe it's because of this reward standard deviation that's being subtracted. We don't really know if this is a good thing to do anymore, do we? Gamma. Okay. We'll see if that runs. I'll be right back. Well, hello there. Um, that's a result. It trains. It suddenly actually trains. Cool. Well, this is back to like a reasonable level of progress, wouldn't you say? We have an algorithm, it trains, things are good. Life is good. Let's do that again with advantage normalization on. And we'll see if that does anything different. This is really nice. Right? We'll wait this one out and then we'll see. But I mean, this is kind of great. I can just get rid of this, get rid of this, get rid of this. Eh. We'll play with a few other things, right? It's initialization here. Can I delete this and have it still work? Or does it break it? B returns. Oh, a little instability, but whatever. That. So this still works plenty well. And then the only other thing I want to know is block 0. Is it growing backwards? It is growing backwards. Huh. The fact that those last two are ones is also a problem. Just had a woodpecker jump into my window. Let me go get a picture of this guy. Flew off. Florida's pretty funny. We've got these big woodpeckers. Okay. So these gammas go backwards, which is so funny. Maybe I need to do. Hang on. Yeah, I think it's backwards because we're not bootstrapping the confidence intervals. That's still backwards? Hmm. Maybe this does make sense. I'll just have to think about it more. And I'll look at the PPO paper for a bit, I guess. That's funny. What'd I do wrong? Oh, semicolon. Alright. Oh, actually, it's GAE. The paper we need. This is like a TD residual, right? Where's this approximation? Yeah, so here we have... Oh, but you're supposed to use the last gamma. So very close. I think here you can do K, right? Let me see if this runs. Yeah, the bootstrap is very important. This next. See what I broke. Gamma is buff. This is all stuff that we're going to be able to test in the C file. Did that fix it? It did fix it. Well, that's great. I believe it fixed it, right? Oh, yeah. No, now it's reversing. Or just even-ish? Hard to say. Oh, no, it's not. Hmm. This is also... Is this how you bootstrap this? Let me think. I know this is. Do you still need the exponent factor? You shouldn't. It's gotta be just not doing the bootstrapping correctly, right? I gotta run soon as well. A meeting. But we will see if we can get a little bit of progress. Okay, so what's happened here? It's changed, right? Yeah, I think it changed. Gamma's 1. Oh, because you're just storing gammas. There we go. So cool. You still have this one. We have duns. Values mean is 1. Ah. Okay. Would you be willing to do a review if the only thing left is the building and puffer? Yeah, of course. To have time tomorrow for review. Okay. Yeah, let's do that. That sounds great. Absolutely. Should be able to get neural networking. Awesome. I will get some good rest and make sure I'm well ready to do that. Okay. I'm gonna run these last couple of tests real quick. 3, 2. 2, 2. What happened here? Oh, just the bootstrap value, huh? Second to last one. So 1. Because, okay, yeah, that's still fine. I'll just run this real quick through Puffer, and then I'll commit this stuff up in whatever the current state is. Okay, cool. That looks like a value bootstrap gone probably wrong, but that's something for sure. Well, we'll go from there. Um, I will. I gotta go get ready for a meeting, and then I may be back. We'll see. Get some exercise and stuff in as well. But for the couple folks still watching, all my stuff's at puffer.ai. You want to support the project for free? Start the GitHub. Join on Discord if you're interested in getting involved, and follow on X for more. Thank you, and